Problem set 1, there are two problems that's related to quasi-linear utility functions, and both of them are kind of the same. They are similar, at least, in terms of the Pareto set. So I will, because question 2 was went over in the tutorial, I'll not talk about that, so I'll go through problem 3. But the problem 3 has one other complication, because one good is bad good, so I'll explain both of the problems at the same time. I mean, both of the complications at the same time. So first we draw our usual address box. No, that's not good. So I'll separate the two problems. So the first problem is that there is a bad good. So if we have two good, if two goods are both good, then we have usual utility function like this. If one good is bad, I want it as little as possible, so probably it goes like this, right? So if you want to think about it, having less of x is the bad good, but having less of x is more preferred. Having more of y is still preferred, so that's why it's going that direction. So that's the first part. And the second problem is quasi-linearity. So quasi-linear. So what's special about quasi-linear utility function is that they go up in they go higher in a parallel fashion. So basically, they shape like this. So so it moves up, and then at the same x point, the slope is the same. So that's why they are special. So combining these, I think you can get why there's a vertical line in the middle. So still drawing it this way. I will probably use red for this person. So red one moving this way, and the blue one I will try to maximize each time. So the blue, by the way, goes that direction. So it moves so that it's tangent, and these tangencies, remember I said the same slope points, the points with same slope move directly up, so it's parallels. That's why we have a vertical line of intersections. And how to figure out this intersection of these two lines? You can either use the method I used in my solution, or you can use MRS method, right? Because MRS method works because they have the same slope at these points. So when you use MRS method, you can actually solve for x star that's such that it's Pareto optimal. So the next big thing is why there are two horizontal lines there. So that's actually a good thing. I wanted to go back to the original reason why, original way that we are solving Pareto set. It's always fixed one and next the other, right? So if we go up even further, they look like this, right? So, but we don't have any blue line intersecting, so we still want to figure out every point of, we want to fix every utility level and then max the utility of the other person. So for example, at this point, the blue lines keep moving that direction until it hits. When it hits, it's not going to be tangent, but it's going to be something like this. So I'll erase this line because it's kind of confusing. So at this point, they are not really tangent to each other, but they have different slope. But this is the highest thing. This is the highest thing that I can get, right? So I cannot even move a little bit, because a little bit I move, then they are not going to be tangent to, they are not going to touch each other, then there's no allocation that works. So basically, at this point, even if they have different slope at this point, even if they have different slope, it's still the best the blue curves can do. So this point is Pareto optimal. Pareto efficient, I usually call it. So similarly, we have this, which is even worse because the slope is even more different. But then this is, again, for the same reason, it's Pareto efficient. That's why all these points, and similarly, you should think about why these points are, but it's just exactly the same idea. They are not tangent to each other, but it's okay, but this is the best the blue line can do, given fixing the utility of the red lines, which means the player A. So the other thing that may be confusing is why we have these 2 points as dictator points. So as I said in class, the dictator points, which you normally think as these two, should always be Pareto efficient. But the problem comes from that there is a bad good. So what dictator points means is one person has everything, right? So if there's a bad good, if there's a good no one wants, then what it means by one person having everything is one person having all the good things and none of the bad things. That's why it's here. So one person, this is person A, having everything. This is actually wrong. So this is the best. What I said was actually right. So this is the point where A has all the good and none of the bad good. So this is the dictator point for A, and this is the dictator point for B. So these points are actually in the Pareto efficient set as we draw like this. So I think some of you will be tempted to draw this thing. This is not right because these two are dictator points. But in problem 2, in the problem set, it does look like this because these 2 points were still the dictator points.